All right, welcome calculus students. We're going to be continuing our coverage of U substitution that we started the other day. And there's two basic rules for U substitution. And the first one is the power rule. And the power rule is if I have the integral or the antiderivative of u to the n du, then this is equal to u to the n plus 1 over n plus 1 plus c. Okay, so this is very similar to the power rule for integrals that we learned in section 4.1 for antiderivatives. And the antiderivative of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. Except here we're changing the variable to u. Okay, so let's do an example of this. And this example will look a little bit tricky at first, but I want to find the antiderivative of x over the square root of x squared plus 4 dx. Okay, so what I first need to figure out is what form do I want my u substitution in. And so over here on the right-hand side, the form that I'm looking for is the integral of u to the n du, because that's going to give me my antiderivative of u to the n plus 1 over n plus 1 plus c. So the form that this particular example is in is not the best form to see how this works. So I'm going to rewrite it by bringing the denominator up to the numerator. So I have this is equal to the antiderivative of x times the square root of x squared plus 4 dx. And we can kind of see that, I'm looking for, up here, I'm looking for substituting something to the n power. And if I look here, I've got x squared plus 4, and this is actually not the square root. This is actually to the negative 1/2 power. So let's try that again. So if I bring this upstairs, I get x plus 4 to the negative 1/2 power. And so here, we kind of can see right away we want our u to be what's inside, this x squared plus 4. But the problem is that we also need to get this x and this dx in terms of u. Everything's got to be in terms of u in order for us to use this power rule. So what I'm going to do is I'm going to rewrite it in a form. It's a little bit easier to see what we're doing, and it's easier to do when you're first starting out. So what I'm going to do is I'm going to do the antiderivative, and I'm going to take that, what's going to be my u, so that's x squared plus 4, and that's to the negative 1/2 power. And then I'm going to multiply that by x dx. So what I've done is I've taken this x and I've put it next to this dx because it's going to help me see how the u substitution works. Once you get used to it, you don't have to do it, but I do recommend doing it at first. Okay, so the first thing we're going to do here is, is this whole term right here, which I want it to be in red. There we go. So this whole term here, that's going to be my u. So I'm going to let u be equal to just what's inside, which is x squared plus 4. And so this whole thing in the box then becomes u to the negative 1/2 power. Okay, but that still leaves me with having to get what remains, which is x dx, in terms of u and du. So what I'm going to do now is I'm going to differentiate u with respect to x. So I've got du dx is equal to 2x. And then what I'm going to do is multiply both sides by dx. And this is actually the last time I'm going to do this step. But basically all it is multiply both sides by dx. Okay, so now if we look up here, what I'm looking to substitute is x dx. And so what I want to do is I want to kind of lock this up. So I'm going to lock this up down here. All right, so I want to lock up x dx because that is what I need to substitute. So if I solve for this lockup, so x dx is going to be equal to 1/2 du. And if we go back up to our original equation here, then our substitution is the quantity x dx is 1/2 du. Now we've gotten the whole equation in terms of u and du. So now I'm going to start doing my antiderivative using the power rule. So this is going to be equal to the integral of u to the negative 1/2 times x dx, which is 1/2 du. Okay, so the next thing I'm going to do is I'm going to bring that constant out. And I'm not actually going to do that step anymore. So I'm just going to automatically bring the constants out. So I've got 1/2 times the antiderivative of u to the negative 1/2 du. And so using the power rule, here n is equal to negative 1/2, and n plus 1 is going to be equal to 1/2. So the antiderivative here is equal to 1/2 times u to the n plus 1, which is 1/2, over n plus 1, which is 1/2, plus c. And as you can see here, the two 1/2s cancel, and that leaves me with this is going to be equal to the square root of u plus c. Now, the very, very last step that you need to do is put your u back into this equation. Don't leave it in terms of u. Because what I'm actually solving for here is I'm solving for the antiderivative of x over the square root of x squared plus 4 dx. And so I need this in terms of x. Go back here. I know this is going to be equal to the square root of u plus c. And so u from up here was x squared plus 4. So I'm going to make that substitution, and this is going to be equal to the square root of u, which was x squared plus 4, plus c. So if I go to the page, then my answer is going to be this is equal to the square root of x squared plus 4 plus c. All right, and you can always verify that this is correct by taking the derivative, and you can prove to yourself that you get the antiderivative. Okay, let's do another example. All right, so let's say, for example, I've got, or I want to find the antiderivative of sine cubed of x cosine of x dx. Now, this looks like it might not be a power rule form, so I'm going to rewrite this. So whenever you have these trig functions, you want to take the exponent out so you can kind of see what's going on. So this is really the antiderivative of sine of x cubed times cosine x dx. And so the form I have, I've got something to the third power. So this is the power rule. I've got u to the n. So on the side, I always want to kind of write my form to remind myself. So I've got the form is is the antiderivative of u, in this case, is to the third du, which is going to be equal to u to the fourth over 4 plus c. That's the form I want. And so going back over to the antiderivative, I'm first going to look at doing a u substitution on this first term. So I'm going to let u be equal to sine of x. And if I let u be equal to sine of x, then this term, first term, just becomes u cubed, which is what I'm looking for. But I still have to substitute for this cosine of x dx term. So I'm going to lock that up. And I'm going to go back down here to this u, and I'm going to differentiate both sides. So I've got du is equal to the derivative of sine is cosine of x dx. All right, so notice that my thing that I need to substitute that I locked up here is exactly what the derivative is. So this cosine of x dx is my du. So this problem is a lot easier than it looked originally. So if I make my u substitution, then this is going to be equal to the integral of u cubed du, which is u to the fourth over 4 plus c. And then the very last step is you just substitute your u back into the equation. So therefore then my integral of sine cubed of x, or sine of x cubed, cosine of x dx is equal to u to the fourth, but u is sine of x, so that's going to be sine of x to the fourth, which I'll write it like this, over 4 plus c. And that's how you do it. And again, if you want to check your answer, take the derivative and make sure that your derivative is what is in the integrand. Okay, do one more that's a little bit trickier. And so watch this one carefully. So I've got, for example, let's say I want to take the antiderivative of x over the square root of x plus 3 dx. All right, so I'm going to rewrite everything like I did before. So I'm going to write this as the antiderivative, and I'm going to bring that denominator up top. So I've got x plus 3 to the negative 1/2, and then I'm going to put that x and dx together. And then I want to ask myself, what form am I looking for? So the form I'm looking for my substitution is the antiderivative of u to the n du. Okay, and you can kind of see why maybe this is going to be tricky, but if our u is going to be x plus 3. And when we take the derivative of u to get du, then I'm just going to get dx. So that's going to leave this x without having a substitution in terms of u. And I'll show you how to deal with that. So let's first use the normal procedure that we've been using. Okay, so the first thing I'm going to do is I'm going to let u be equal to x plus 3. And if I do that, then here I've got this whole term is going to be u to the negative 1/2. And now the next thing I'm going to do is I'm going to differentiate. And if I differentiate, I get du is equal to 1 dx. So this dx is my du. Now, you can see the problem here. The problem is that I don't have a substitution for this x. So in order to find a substitution for this x, whenever this happens, and this is always going to happen if the orders of the x's are the same. See, this is a first order and this is a first order. So we're going to have this situation where we're going to have an extra x floating around. Or if this was x squared on the bottom and x squared on the top. Whereas if I had x squared on the bottom and x on the top, then I wouldn't have to do this. Okay, so in order to solve this problem, what we need to do is go back and actually look at this equation again here. And so I said that u is equal to x plus 3, and I still need to substitute an x. So you actually use that equation and you solve for x. So x is equal to u minus 3. And if I do that, then that gives me this x in terms of u. So now I've made the substitution complete, so let's write this out. So this is equal to the antiderivative of u to the negative 1/2 times x, and x is u minus 3, and then times dx, which is du. Okay, so the next thing I want to do is, in order to integrate this, I need to get this in power rule form. So I'm going to multiply these two things out here. And if I do that, then I get the antiderivative of u to the negative 1/2 times u to the first power is u to the 1/2. Minus 3 times u to the negative 1/2 du. Okay, so what I'm going to do now is I'm just going to take the time to make sure that I get this correctly. So here n is 1/2, so n plus 1 would be 3/2. And here n is negative 1/2, so n plus 1 is 1/2. Okay, so I'm going to do my antiderivative using my power rule. So I've got u to the 3/2 over 3/2 minus 3 times the antiderivative of u to the negative 1/2, which is u to the 1/2 over 1/2 plus c. And I'm going to clean this up a little bit. So this is equal to 2/3 u to the 3/2 power minus 3 times 2, so that's minus 6. Because over here I had this 1/2 and this 2 goes up and is multiplied by 3. Okay, so then I've got 6 times u to the 1/2 plus c. So the last step here is just substitute your u back in. So I've got 2/3, and u originally was x plus 3. So I've got 2/3 times the quantity x plus 3 to the 3/2 minus 6 times u to the 1/2, which I'm going to write as u to the square root of u. So that's 6 times the square root of u, and u was x plus 3 plus c. And that's the antiderivative above. Now if you want to check this, it's a little more complicated because you have to take the derivative, and then once you take the derivative, you've got to get it into a single quotient. But if you do so, you can prove that you get to the original integrand in the problem. All right, so that's about as tricky as it gets as far as this class goes in terms of the u substitution for the power rule. Okay, so up next, we're going to do the trig rules for u substitution, and I will see you shortly.